Namaskar everyone. I hope all of you are doing well. So this is the second lecture on calculus for physics. And today we will complete differentiation and we'll hold one or two more classes for integral calculus. So we'll see exponential and logarithmic functions today. Okay, so the first formula is ddx of e to the power x, which is e to the power x. Now you see the numbers given over here are in accordance with the previous chart that I have provided you in the other video. Okay, so there formula number 10 was ddx of e to the power x, which is e to the power x. Formula number 3 was ddx of log x, which is 1 by x. Okay, so after that you have this product rule, which is ddx of uv, u ddx of v plus v ddx of u. Now we dealt with this product rule in the previous class, I guess. Next is ddx of u by v, which gives you v ddx of u minus u ddx of v divided by v square. Okay. So till you become an expert in solving calculus problems, you'll have the habit of writing down the formula on the right side of your page. I mean on the side note. Okay. In that manner, you can memorize the formulas quickly. So the first question. ddx of x log x. So here x is taken as u and log x is taken as v. Therefore the formula says u ddx of v plus v ddx of u. Therefore you have u ddx of v, that is x ddx of log x plus log x ddx of x, which is v ddx of u. Now ddx of log x gives you 1 by x, okay, and ddx of x gives you 1. All right. Therefore in the first part you have x into 1 by x plus log x into 1. Therefore x into 1 by x is 1 and log x into 1 is log x. Therefore the result is 1 plus log x. Question number 2. ddx of 3x square into log x. So 3x square is taken as u and log x is taken as v. So you have 3x square ddx of log x, which is u ddx of v, plus log x ddx of 3x square, which is v ddx of u. So ddx of log x gives you 1 by x and ddx of 3x square gives you 6x. So now what you have here is 3x square into 1 by x plus log x into log x into 6x. So once you divide x square by x, you get x. Therefore in the first term you'll get 3x and here you'll get 6x log x. Okay. So when you take 3x common, what remains is 1 plus 2 log x inside bracket. So I hope question number 2 is clear. Question number 3. This is of the u by v pattern. Okay, the division pattern. So ddx of log x divided by 5x square. So log x is taken as u and 5x square is taken as v. So v ddx of u, it's 5x square ddx of log x minus u ddx of v, that is log x ddx of 5x square, divided by v square, so 5x square whole square. Okay, so in the denominator you get 25x to the power 4. In the numerator ddx of log x gets you 1 by x and ddx of 5x square gets you 10x. Okay, so after calculation you'll get 5x square into 1 by x will get you 5x and in the second term is 10x log x. So you can take 5x common in the numerator. So in the next step you see we have taken 5x common. So 5x taken common leaves inside the bracket 1 minus 2 log x divided by 25x to the power 4. So after calculation you'll get 1 minus 2 log x divided by 5x to the power 3, that is 5x cube. So next question number 4. So here you have ddx of e to the power x into log x. So e to the power x is taken as u and log x is taken as v. So by the product rule, e to the power x ddx of log x plus log x ddx of e to the power x, that is u ddx of v plus v ddx of u. So ddx of log x will get you 1 by x, okay, and ddx of e to the power x will get you e to the power x. So what you get here, like you can take e to the power x common and what remains behind is 1 by x plus log x. Therefore your answer is e to the power x 1 by x plus log x. So these are the homeworks for you to try. I'll try to put the solution in the comments, okay, tomorrow. So the other part is U form differentiation. So you had that formula number 14, if you recall the previous chart, or if you see the previous chart. So ddx of u to the power n, it tells n u to the power n minus 1 ddx of u. So this ddx of u actually repeats in our in the other formulas also, which we have dealt with so far, but we don't write it. You see, we had ddx of x to the power n as n u to the power, sorry, n x to the power n minus 1 ddx of x again, we can write down. Okay, so I'm repeating this thing again, like ddx of u to the power n is written as n u to the power n minus 1 ddx of u. Okay, so in accordance with this particular formula, I'll be writing down ddx of x to the power n. So it tells you n x to the power n minus 1 and ddx of x again in accordance with this formula. Okay, so ddx of x is 1. All right, so we don't write this, since we already know that ddx of x is 1, so we don't write this in the formulas where you have ddx of x to the power something, ddx of log x, ddx of sin x. In those kind of formulas, you don't write this repetition. Okay, so finally it will get you n x to the power n minus 1 only. But when you have, suppose you are differentiating with respect to x, and here you have y, z, u, any other quantity, okay, v, w, then you have to repeat this, just like in these patterns that we'll see now. So here the repetition is ddx of u. So the next formula is ddx of k u to the power n. So k is a constant here, you take k outside, what remains is ddx of u to the power n. Okay, so ddx of u to the power n will get you n u to the power n minus 1 ddx of u. Okay, so the next formula, ddx of log u. So ddx of log x was 1 by x just, right? So ddx of log u is 1 by u ddx of u again. ddx of sin u is cos u ddx of u. Okay, ddx of cos u is minus sin u ddx of u. So previously you had ddx of cos x minus sin x only. Okay, so in accordance with the present form, we could write ddx of x again, which would definitely give us 1. Okay, so next ddx of tan u. So this gives you sec square u ddx of u. Number 7, ddx of cot u. This gives you minus cosec square u ddx of u. Number 8, ddx of sec u gives you sec u tan u ddx of u. Number 9, ddx of cosec u gives you minus cosec u cot u ddx of u. And number 10, ddx of e to the power u, that gives you e to the power u ddx of u. Now here you can also write this as ddx of e to the power y. So that would give you e to the power y ddx of y again. Alright, so in accordance with these formulas, we see question number 1, ddx of y cube. Okay, so here y is treated as u. Okay, so and your n is 3, right? So n u to the power n minus 1, that is 3 y to the power 3 minus 1. Okay, and you have ddx of y, the repeated part. Okay, so 3y square dy by dx, or ddx of y, is your result. Next question, ddx of 5 sin y. 5 taken common, what remains is ddx of sin y. So ddx of sin y will get you cos y ddx of y. Okay, and 5 is carried over. So your answer is 5 cos y ddx of y. Question number 3, ddx of 5 sin y cube. So 5 taken common, you have ddx of sin y cube. Now y cube needs to be treated as u. So you have ddx of sin u as cos u ddx of u again. So ddx of sin y cube as cos y cube ddx of y cube. Okay, so ddx of y cube, you have to solve it again. Okay, so ddx of y cube is 3y square and ddx of y again. So your final result is 5 into 3 will get you 15. So 15y square taken over here, then you have this cos y cube, and you have this ddx of y. Number 4, ddx of log z cube. So here z cube is taken as u. Okay, so 1 by u ddx of u again, that is 1 by z cube ddx of z cube again. Now ddx of z cube is 3z square ddx of z, that is ddx of u to the power n we have performed here. Okay, so I hope this is clear. Okay, we could do one more step here. All right, so let's do that. So you have this 3 by z d dx of z. Here z square and z cube, one z will remain in the denominator. Okay, so this is your answer. Next, ddx of e to the power x square. Now x square is u here, so e to the power u ddx of u again. Okay, so e to the power x square. Now ddx of x square is 2x, and this I have done this repetition part just to show you in accordance with the ddx of u to the power n formula. Once you understand this, you can avoid this part, not necessary. So ddx of x is 1, right? So the repetition part happened here, but since it is ddx of x, this will get you 1. So your answer is 2xe to the power x square. Okay. So next question, question number 6, ddx of log x square. Now log x is taken as u here. Okay. So you have to see it as ddx of u square. So 2u to the power 2 minus 1. There is 2 log x to the power 2 minus 1 ddx of log x. So 2 log x to the power 2 minus 1 will get you 2 log x, and ddx of log x is 1 by x. Therefore your answer is 2 by x log x. Okay. So with this the u form, the exponential form and the logarithm form are over. You will try doing this homeworks. I'll provide you the solutions. I'll try to put that in the comments. Okay. Thank you. Stay awesome.